somewhat interesting. I found, like, personally what I found kind of interesting, I don't know, some of it was a bit boring.
I'm only actually here to please my parents, and that's not a fashion design video tape.
Oh, okay. So this isn't your main love, is it? This isn't. They want you to get a degree from UWA. Okay, that's really cool. How long have you done fashion design for?
A year and a half.
Yeah. What do you like more, like women's wear, men's wear?
Women's wear.
Yeah.
I just like that kind of
Yeah.
physical.
I don't really get that in philosophy. Not handmade at all.
So,
That's cool. And do you have to make everything yourself? Like you design it, and then you actually sell it, everything, don't you? Yeah.
Okay, guys, let's get started. Okay, so this week we're talking about counterfactual theories of causation. So last week we talked about process theories of causation. Process theories of causation are the descendants of mechanistic theories of causation, and mechanistic theories of causation been kicking around for quite a long time, quite intuitive, quite difficult, as you saw, to make something precise out of the sort of intuitive idea that, you know, causation is a matter of things smacking into each other. We have to go to something quite advanced. What we have to have, or at least the sort of contemporary process theories, involve trajectories through space-time which intersect, and where they intersect, they transfer conserved quantities between each other. And then causation is a matter of those conserved quantities getting transferred. Okay, so one of the big problems for all process theories, in fact any sort of mechanistically minded theory of causation, is that any causation by absence is difficult to manage, right? So we saw this and we talked about this briefly at the end of the last lecture, and we had some ideas, which was quite good, about how you might address this issue, but let me just briefly remind you of what the problem is. Suppose that I fail to water my plants. When I fail to water my plants die, right? So the cause is the failure and the effect is the death. If we want to model this using the process theory, what we have to have are two processes which interact. The problem is that my failure to water the plants doesn't really look like the right kind of process insofar as it is a process, or indeed may not even be a process. And so can't really plausibly interact with the world line of the plant, right? It's really difficult to tell a story about how the lack of something can be a process or can be understood in a sort of process-oriented way. And because it's difficult to understand these absences in this process sort of way, or even just a sort of base mechanical way, it's quite difficult to understand how an absence could, you know, smack into something else in order to produce a mechanistic effect. Looks like it's hard to tell a story about causation by absence. Okay, so there are strategies for solving this if you're a process theorist. You don't have to give up on the process theory of causation. So one of the things that came up at the end of last lecture was this idea that maybe there's something process-like in the neighborhood that you can appeal to, right? Maybe something about what's going on with the plant itself can be sort of cashed out in terms of a process, sort of dehydrated process. Or maybe you can give an account of what's going on with me, that can be understood in a process-like way and tell some sort of causal-like story, something that's, you're never going to get something that's exactly the process story, but you might be able to get something in the neighborhood. And the thought was, well, maybe that's enough, right? Maybe if we tell that story, we've got enough of the resources to account for causation by absence when we're dealing with these sorts of cases. So look, there are options for the process theorist. If you're going to write on this topic, and you have the option of writing on this topic, it's worth looking at some of the responses that people like Phil Dow, who's one of the guys that put forward this position, some of the responses that they have. And in fact, that sort of quasi-causation response that came up at the end of the lecture is the response that he favors, and he makes that precise. So if you're interested, you can check that out. Rather than digging into the details of the sort of back and forth over that topic that you find amongst process theorists, we're going to look at a completely different theory of causation. These are counterfactual theories. They are, it's interesting, the history of these theories is somewhat fascinating. For a long time, people just dismissed these out of hand as utterly implausible. And then in the 1970s, I guess, David Lewis, a fairly famous metaphysician, rebuilt a counterfactual theory of causation and showed how you could have one that makes sense. These theories are still pretty weird, I should say. We're going to be dealing with modal notions, so we're going to be dealing with some of those possible worlds that I introduced in the first lecture, and we're going to use those to give an account of causation. So you're going to be understanding causation in the actual world, right? So actual instances of causation. You know, I'm going to throw this pen across the room. I feel sorry for the people that come in here afterwards. All the stuff's like thrown around everywhere. When I throw that pen across the room, we're going to understand any causal effects that had, like the sound it made, in terms of things that don't happen in our world. Right? So we're going to understand it in modal terms. Sounds weird, actually turns out to be quite versatile, and for some people quite plausible. I'm quite attracted to this theory. Okay, it's a bit complicated as to how this works. We're going to go slowly. We're going to start with counterfactuals, because in order to understand a counterfactual theory of causation, you need to understand what counterfactuals are and how they work. And then we're going to parlay that into a full-blown counterfactual theory of causation. Okay. So I'll give you a brief reminder of possible worlds, then we'll go through the counterfactuals, and then we'll put that into the theory of causation. Then at the end, I'll give you some counterexamples to this theory of causation. So just as in the process theory, absence causation looks like it poses a problem. There's a whole bunch of trouble cases for the counterfactual theory. These are quite fun to go through. They're quite tricky to solve, although there are, again, solutions available. Okay, so remember the possible worlds. So possible worlds was this thing I told you to try to take seriously if you can, and the way we're thinking about it is as a way of modeling modal stuff, about what could be the case, what might be the case, what has to be the case, and so on. And we do that by thinking about the actual world as just one of many different universes that there might be, right? So the actual world is a complete space-time, and then there are all these other complete space-times that are disconnected from our complete space-time, and each one represents a different way that the actual world could be. Okay? So in our actual world, we're all in this lecture theatre, but in one of these other worlds, you know, we're somewhere else. Maybe we're at Adventure World. That still exists, right? I haven't lived in Perth for a while. Cool. Maybe we're at Adventure World, or maybe at a further out world we're living in America. Maybe at this world right out here we're living in Mars or something like that, going to a lecture on Mars, on Martians. Okay, so what we saw with these possible worlds accounts is an analysis of modal talk, right? So P is possible if there exists a possible world in which P, right? If in this space of many universes, there is a universe that sort of bears witness to this fact, right? P is necessary if in every world that exists, P, right? So there isn't a world in the space of possible worlds in which P is false, or P doesn't occur, or P doesn't exist. Now, as we saw, there are different kinds of worlds. So these lines, the different colors, represent different kinds of modality, different kinds of possibility that we might be interested in, right? So this blue line here might represent physical possibility, right? The worlds that have similar laws of nature to our own And often in science, we're very interested in what happens in physically possible worlds. But just, in an everyday way, we often say things and make judgments about what's going on based on physical possibility. Then out here, so the reason I've given you 3 rings is because these sort of map onto the most common divisions that you find in the space of possible worlds. You've got physical possibility. I've given you 4 rings. Pretend there are 3 rings. You've got physical possibility. Then you might have metaphysical possibility, right? If you think that there are sort of metaphysical laws or something stronger than physical laws, we can talk about that a little bit later if you want. It's sort of a contested notion. Maybe there isn't such thing as a metaphysical possibility that's not a physical possibility, or metaphysical possibility that's not just a possibility simpliciter. And then out here you come to logical possibility, right? So basically things that are consistent are going to be out. Like any consistent way that a world could be is going to be out there. And these metaphysical cases might be consistent ways the world could be that are constrained by sort of like metaphysical laws or something like that. And these are going to be ways the world could be constrained by physical laws. Okay, so what we can do is actually order the worlds in terms of how similar they are to the actual world, right? So we're going to imagine you put the actual world, imagine you've got all these, a room full of spheres, right? This is how I think about possible worlds. One of them is the actual world, right? So you're going to dig through all of the spheres, you're going to find the actual world, and then you're going to look at each sphere. I mean, not literally, this is a thought experiment. You're going to look at each sphere, and you're going to hold it up to the sphere that you've taken to be the actual world, and you're going to see how similar they are. And you're going to make determinations of similarity based on whatever you might be interested in. So, for example, you might look at all the worlds, right, and determine how similar they are to the actual world in terms of the laws of nature, right? So they might all have different laws of nature, but you might be able to get a really nice ordering of all the worlds based on how much they differ from the actual world in terms of what the laws are. Or you might, I mean, that's a sort of natural carving, a natural similarity relation that you might go for. But there are lots of other similarity relations that you might be interested in. It really depends on the context, depends on what the sort of pragmatics of the context might be. So, for example, if you're interested in, I don't know, I heard someone talking about fashion design as I walked in. If you're interested in fashion design, you might be interested in ordering these worlds in terms of how similar they are with respect to fashion compared to the actual world, right? If you're interested in sort of, I don't know, exploring the outer reaches of fashion possibility space, as some fashion designers are. But you can see that depending on what you're interested in, you kind of set the conditions of similarity, and then you go into the ballroom, the ball pit, you know, those ball pits that you played in as kids. One of those was the actual world, but you didn't know that. And then you compare all of the worlds based on whatever dimension of similarity you end up being interested in. Okay? So we're going to order the worlds in terms of how similar they are to the actual world, okay? Now, as I said, there are lots of different ways you can do the ordering. We're going to be interested in physical or nomological similarity. This is the ordering with respect to the laws of nature, right? How similar the worlds are with respect to the physical laws. As I said, each colored line represents a kind of similarity. What we're going to see is that there are some worlds that are much closer to the actual world than other worlds, right? So when we make these similarity judgments, we compare all of the worlds in terms of the laws of nature, we're going to see that some worlds have very similar laws of nature to our world, and some worlds have very different laws of nature. Okay? Good. Now we're going to use that ordering to analyze a certain class of modal claims. And these modal claims are counterfactual claims. Counterfactuals are statements about what the world might have been like or would have been like had certain things that in fact obtain, not obtain, right? So they're contrary to fact. So think about all the facts of the matter that there are. A counterfactual deals with how things might have been had those facts been different, very roughly, right? So suppose that Susie throws a rock at a bottle and it smashes, right? We know that this happens because we observed Susie do it. Here's a counterfactual about that case. If Susie had not thrown the rock, the bottle would not have smashed. Right? It's a modal claim, it's a counterfactual claim, because as a matter of fact she does throw, the bottle does smash, but we're interested in what would have happened had she not thrown. Okay? Similarly, suppose that no one presses the button right? There's a big red button sitting in the president's office. No one presses the button, and because no one presses the button, a nuclear holocaust does not ensue. Here's a counterfactual about that case. If the button had been pressed, there would have been a nuclear holocaust. Okay? Right, to the plants that I didn't water. Right? I never watered my plants, and they died. But here's a counterfactual about that case. If I had watered my plants, they wouldn't have died. Or at least they might not have died. I'm a bit shit when it comes to looking after plants. So there are really two kinds of counterfactuals. There are would counterfactuals and might counterfactuals. And you'll encounter this distinction later on when we look at some of the time travel literature, because people, when they're talking about time travel, are sometimes interested in would counterfactuals, sometimes interested in might counterfactuals, and the distinction matters there. For the most part, we're going to be interested in would counterfactuals when we're thinking about causation. So it's no accident that I gave you these three different cases. What you can see from these three different cases is that they're all apparently causal claims, or all seem to be connected to instances of causation in some way. I mean, this is one of the motivations for trying out counterfactuals as a way of understanding causation in the first place. Because whenever you have an instance of causation, looks like there's a nearby counterfactual that's true. And if you can sort of tell a plausible story about the truth of that counterfactual, maybe you can analyze the instance of causation that sort of gave rise to the counterfactual in terms of the very counterfactual itself. Okay? That's what we're going to try and do. All right, so what we've got so far is the actual world. We've got all the possible worlds, and they're ordered with respect to the actual world in terms of how similar they are to the physical laws. And on the other hand, we've got these things, counterfactuals, which are contrary to fact modal claims about what would be the case or what might be the case if the world had been different. Now we're going to connect those two things up by using the ordering of worlds to understand the situations in which these claims are true and false. Okay? Okay, so just a bit of notation. We're going to use the box arrow to represent counterfactuals. So when you see P box arrow Q, that means if P had been the case, then Q would have been the case. When we see not P box arrow not Q, that means if P had not been the case, then Q would not have been the case. Okay? So this is different from just the ordinary arrow, the indicative conditional, which you might have come across in logic or just in philosophy generally. That the standard arrow is just if P then Q, right? It doesn't have any sort of counterfactual substance to it, whereas this box arrow is used to represent the counterfactual. Okay, so possible worlds represent a model modality. They tell us how things might have been, but they also tell us how things would have been and could have been, and so on, right? So you can already see that an account of possible worlds which is used to model modal claims generally, you're going to be able to push into an account of counterfactuals, because counterfactuals are just a sort of class of modal claims that possible worlds were brought in to handle. Okay, so how do we do that? So here are the truth conditions, right? The situations under which a counterfactual is true or false, according to a possible world semantics. This possible world semantics shows up in a range of areas in philosophy. It's not just used to handle counterfactual claims. It's a very powerful tool. David Lewis's book On the Plurality of Worlds makes the case for this way of speaking about modal claims and way of analyzing counterfactuals, and the case is very powerful. So here's the truth conditions. P box arrow Q, so if P had been the case, then Q would have been the case, is true if there is some possible world in which P and Q that is closer than any possible world in which P and not Q. So let me explain that, and I'll give you an example to help you grip what's going on. So here's the actual world. Here's our ordering in terms of laws of nature, right? One of these worlds, right, or a ring of worlds around the actual world, more likely. So we'll come back to here. We'll use this picture. Yeah. So you see this ring of worlds around the actual world. Those worlds are closer to the actual world than any other worlds, right? They're just more similar in terms of the laws of nature, say, which is what we're dealing with here. And when we are looking at the counterfactual, what we want is the way that we analyze it is we look at all the worlds that are really, really close to the actual world, and we see what's going on with those worlds. And in particular, we look at all the worlds in which P holds, right? And then we look to see what's going on with Q in those worlds. And if in all of those worlds in which are P, you've also got Q, then the counterfactual is true. Because all of the worlds in which you've got P and not Q are sort of much further away from actuality. So you're using that ordering to give you the relevant truth conditions. So let's have an example, because it's much easier when you think of an example. Come back to, I'll complete the analysis, then I'll give you an example. So not P, box arrow, not Q. If P hadn't been the case, then Q wouldn't have been the case. Is true if and only if there's some possible world in which not P and not Q that is closer than any possible world in which not P and Q, right? It's the same analysis. I've just pulled out the negated counterfactual to help you out. Basically what's happening is that the world in which P and Q is closer, the world in which the antecedent of this is true and the consequent is true is closer than any world in which the antecedent is true and the consequent is false for both of those. Okay, so I'll give you an example. Hopefully this will help to bring it together. If Susie had not thrown the rock, the bottle would not have smashed, right? Under what conditions is this claim true? Well, we look at all of the worlds that are similar to the actual world. And then we look at the closest worlds, the worlds with the most similar laws of nature to the actual world, right? And we see, we pick out those worlds in which Susie throws the rock. So we're looking at all the worlds that are sort of clustered around the actual world in which Susie throws the rock. If in those worlds the bottle smashes, then the counterfactual is true. If in those worlds the bottle does not smash, then the counterfactual is false. So the idea is that when you've got laws of nature that are similar to the actual world, and you've got a similar kind of event happening in one of those worlds, should be the case for the counterfactual to be true if Susie's having thrown the rock would smash the bottle, that in any world in which you've got similar laws of nature, her throwing the rock would lead to the smashing of the bottle. If you've got worlds that have similar laws to ours, in which she throws the rock and the bottle doesn't smash, then you've got a counterexample to the counterfactual claim. Okay, so we need to expand on this a little bit. Yeah.
Why not say that they must be worlds with the same laws of nature?
Why not worlds in which they're the same laws of nature?
You don't think that event would occur?
Okay, so what we want to do is we want to look at worlds in which P, right? So in which Susie throws. If they have exactly the same laws of nature, right, and determinism is true, then it follows that the bottle smashes in every one of those worlds, right? You might want it to be you might not want to tie it so closely to deterministic laws of nature, right? If the laws of nature are not deterministic, or indeed if you just don't want to tie it so closely to deterministic laws, then you're going to have to deal with worlds that are similar to ours in order to look at worlds in which not Q. Because any world that's the same as ours with respect to the laws, and in which Susie throws the rock, determinism is true, then the bottle has to smash, right? So you sort of have to look at worlds that have, from the perspective of our world, a little bit of a violation of the laws of nature, right? So I'll expand on this in a second. The bottle gets thrown in our world. It depends on which counterfactual we're testing, right?
Yes.
So if we're testing this counterfactual, if P, then it would be the case that Q, then we don't have to look any further than the actual world. You're right, because we can just look into the actual world, we see that she throws, we see the bottle smashes, and that's enough to make the counterfactual true, because the actual world is closer to itself than any other world, right? It's more similar to itself. The similarity relation's reflexive. If it's this counterfactual, though, if Susie hadn't thrown, then the bottle wouldn't have smashed. We have to go to all these worlds in which she doesn't throw, right? But they can't have the same laws as ours, because in our world she throws, and the laws determine that she does, right? So we have to look at worlds that have similar laws of nature, right? This will become a bit clearer when I go through the actual similarity metric that he uses. So remember I said that these worlds are ordered, right? And they're ordered in terms of similarity, and it's similarity in the laws of nature. You might wonder how that similarity metric actually works, and exactly what goes into a sort of similarity judgment about the laws. And Lewis has got a story about this. So the first thing he says, when you're judging which worlds are most similar to ours, is that it's of the first importance to avoid big, widespread, diverse violations of law. Now, what he means by this is not exactly what is sort of traditionally meant by a violation of a law of nature. What's traditionally meant by a violation of a law of nature, especially when you're dealing with our world, is a violation of the actual laws, right? So Jesus getting resurrected looks like it's a violation of the actual physical laws about conservation of energy, right? What Lewis means is it's actually a relation between two worlds. So you take the actual world, you go to some other world, you look at what happens in that other world, and if what happens would be a violation of the laws, if the laws of the actual world applied there, then that's a violation of the law in the relevant sense. So you compare the worlds, they've got similar laws, but you use the laws of our world to judge whether that event would be a violation, whether that event would be impossible given the laws in the actual world. So when you say it's of the first importance to avoid big, widespread, diverse violations of law, you're lining up all the worlds in terms of how similar they are to the actual world, right? If, given the laws of the actual world, those worlds have some stuff that just looks completely impossible, then they have widespread violations of law. So an example of this would be, suppose Jesus never gets resurrected in the actual world. It's not hard to imagine. Go to a world in which he does get resurrected. From the perspective of our world, that world has a very big miracle in it, right? But from the perspective of that world, it may be that it doesn't have a miracle because the laws allow for resurrection in that world. The laws are different, right? But from the perspective of our world, it's a violation of the laws, okay? So we're always, when we're thinking about violations of law, we're always thinking about with respect to our world, with respect to the actual world. Okay, so you order the worlds based on how similar they are to the actual world with respect to violations of law, right? Then you are supposed to maximize the spatiotemporal region of particular fact, right? So imagine you've got a world that has some kind of miracle in it, something different that occurs compared to our world. But, you know, by and large, everything else is basically the same, right? So Jesus gets resurrected, but, you know, no one cares, no one pays any attention, and the world just sort of is very similar to our world, even though it's got this sort of blip in the laws, right? That would be a world that's very similar to our world on this second condition, right? You've maximized similarity with respect to sort of spatiotemporal regions, even though you've got violations of law, right? So you start by ordering in terms of violations of law. Then once you've ordered of those ones, you then reorder the ones that are in terms of violations of law, in terms of how similar they are with respect to local matters of fact. Then you order in terms of simple violations of law. So the first one was big miracles, right? So Jesus being resurrected, I don't know, parting the Red Sea. What else goes on in the Bible? Stuff like that. Loaves out of fishes. What is it? No, not loaves out of fishes. He makes bread out of his hair or something. Out of less bread. He makes bread out of less bread and fish out of less fish. That's right. Makes lots. He feeds all the masses with a loaf of bread and some fish, which is a bit dodgy if you think about it. So that's supposed to be a violation of law, but you might think that some of those violations are more serious than others, right? So Jesus getting resurrected, you might think is a big violation, but making the fish out of the other fishes, yeah, it's a little violation. It's not so bad. Maybe you don't think that. Maybe you think that's a big violation as well. But you can think of little violations, right? Jesus getting resurrected is a violation of the laws of conservation of energy. It's a big violation, but you can imagine a sort of small violation of the laws of conservation of energy, where just a little tiny, minute piece of energy is not conserved. That would be a sort of small violation of law. And then finally, it's of little or no importance to secure approximate similarity of particular facts. So this was exact match, this second condition, right? So the world had to be exactly the same, even though there might have been some small violation of the laws. This is similarity, right? So basically, you know, look, if it looks similar, he doesn't really care if it looks similar or not. That's not very important. Whereas violating the law and getting maximum matching is important. For the most part, we can just focus on this first condition because for the purposes of most counterfactuals, that's where a lot of the work is done with respect to violating the laws and seeing how similar the world is with respect to the laws. So we come back to this case. If Susie had not thrown the rock, then the bottle wouldn't have smashed, right? So to evaluate that counterfactual, we go to a world in which Susie doesn't throw the rock. Now, in the actual world, Susie does throw the rock. Moreover, the laws of nature we're going to assume are deterministic. Because they're deterministic, Once you've got the initial conditions of the universe, right, the way the universe started, and the laws, you run them forward, they're just going to guarantee that Susie throws the rock. Okay? That's just how determinism in the laws works. Given that determinism is in the laws, any world in which she doesn't throw has to involve some violation of the laws with respect to the actual world, right? From the perspective of the actual world, the laws in that world, from the perspective of the actual world, Susie's not throwing the rock has to look like a miracle. Yeah.
That would assume that every world has the same starting state, even if they have the same laws.
Yeah.
If you run a different state forward with the same rules, you get different.
Yeah, it depends on whether you think the starting state is a law or not. Some people think the starting state is a law. That is a tricky issue, right? So depending on what the status of the initial conditions are, you might think that, or if there is a state that you start with. But let's just suppose that there is a state and it's a matter of law, just to make things simple, right? That's going to complicate things. I mean, already we're making it simple with determinism, yeah? So every world that looks like ours is going to have... It's not going to be any world that's got the same laws as ours is not going to be a world in which Susie throws. It is going to be a world in which Susie throws the rock, because if it has the same laws, then following from the initial conditions, it's just going to guarantee that Susie throws the rock. So you go to a world that's got a little bit of a miracle, right? It's got slightly different laws that enable, from the perspective of our world, that enable Susie to throw the rock, and you see what happens if she doesn't throw the rock in those worlds. If she doesn't throw the rock and the bottle smashes anyway, right, then it doesn't look like her throwing the rock is responsible for the smashing of the bottle. Because worlds that are very similar to ours, in which she doesn't throw, the bottle just spontaneously smashes, right? And you would expect, if she's genuinely responsible for smashing the bottle, and that's a genuine sort of causal relationship, that worlds that are very similar to ours in which she doesn't throw would be worlds in which the bottle just doesn't smash, right? That causal link gets broken as soon as she doesn't throw. If she doesn't throw and the bottle smashes, then it looks like there's something else that's responsible for the relevant smashing, right? That we're sort of wrong to think that her throwing the rock is what smashed the bottle. Okay. So if she doesn't throw, then if she hadn't thrown, then the bottle wouldn't have smashed. And that's true because worlds in which the laws of nature are similar to ours, in which she doesn't throw, the bottle doesn't smash, right? So there's no extra thing to come in and smash the bottle in those worlds. Okay, so just a little bit more detail about this similarity metric. I know this is complicated, and we'll go through this in the workshop, right? We'll work through some of this stuff to get a real sense of how it works. Once you get a handle on this, though, it makes a whole bunch of stuff in metaphysics of causation much easier to get your head around. So first thing, first importance to avoid big, widespread, diverse violations of law. So here's some examples of big, widespread, diverse violations. Here's our world with normal gravity. You know, turn the inverse square law into an inverse cube law. You got much stronger gravity when that happens, I think. I'm not actually sure about that. Something's going to happen with gravity. One of these two things is going to happen. Mess around with the gravity, and you're going to change, like, globally across the entire universe what's happening with everything. And so you can imagine these different modifications to gravity are going to result in these big, widespread violations of law. Again, thinking from the perspective of our world. We use our world, we use our laws, we look at what's going on in that world, and we see how they match up with our laws, right? If in those worlds gravity is completely different, then it's not going to match up to our laws very well. Okay, so some examples of spatiotemporal region through which perfect match of particular fact prevails, and this is going to help out with your initial conditions thing, right? And this is so. For simplicity, we can sort of just ignore it and work with the first condition in the metric, but this is actually how it gets handled. So you have to maximize the spatiotemporal region throughout which perfect match of particular fact prevails. One way to think about that is that you have to line up the past of the actual world with the past of these other worlds and make sure that the pasts are as similar as they can be, right? So a world in which dinosaurs are out in the past, kicking around, hanging out, that's very similar to our world, but a world in which hobbits are out there in the past, kicking around, that's very different to our world. It's got a very different past, right? So the way that helps with your issue is, with respect to the initial conditions, is if you had different initial conditions with the same laws, you would have a completely different history, right? And so the second thing, the first thing orders with the laws, then the second thing is going to get you the worlds that have the same history, which is going to help with the initial conditions a bit, yeah? So that's going to get all of the worlds in which the initial conditions are the same and the history is the same, and Susie doesn't throw, which means there's sort of a violation in the laws, yeah? Yeah?
I guess that means just like physical space is exactly the same in each, right? So there's a larger region that's right, not just the past, it's like there's a larger volume that perfectly matches up than just the larger history.
Yeah, that's right. That's right. It's not just the history. This is a sort of, for the most part, when you're dealing with causal claims, you're interested in the past causal history, right? You're not so interested in like the future, right? Or stuff that's very spatially far from you, because that stuff's not usually causally involved with you. But you're right, it's not just the past, but this is a useful way of thinking about this second condition. As you match up the past, make sure the past is the same, and then you run the laws, okay? But yeah, it has to be globally, the whole universe. Yeah?
Do you have to assume that from Susie's perspective the world is the same, rather she doesn't move from the world that she throws the rock to a separate world line where the bottle breaks, or vice versa?
Sorry, what do you mean?
Do you have to assume that Susie's world, from her perspective, stays the same before and after the action?
Do you have to assume that Susie's world, the actual world, the world that we started with, when we're evaluating the counterfactual? Right, so when we're looking at what goes on after Susie throws, right? So we start in the actual world. Susie throws the rock, smashes the bottle, right? We go to a different world, and she doesn't throw the rock there, right? Then we look at what happens afterwards. Part of what we're doing there is looking at the downstream effects, right? So we're going to look at whether or not the bottle breaks. If the bottle doesn't break, then the counterfactual turns out to be true back there. But we're also going to look at the entire future, right? So you are looking at the world from the perspective, insofar as I understand what you mean by from the perspective of Susie, where you're just looking at sort of future consequences of her action, then you are going to match that as well, which is similar to what you were asking, right? So a world that's got a very different future is also going to be different, not just a world that's got a very different past. But yeah, you want to pay attention to the downstream effects as well. Okay, so this is an example of what goes on with Susie. So in the actual world, she throws the rock and the bottle smashes, right? If in the closest world to the actual world, the world that's most similar to ours in which she doesn't throw, in which she throws and the bottle doesn't smash, then I think actually that diagram's wrong, as pretty as it is. So what should happen is that she shouldn't throw down here and the bottle should smash anyway, okay? So in the actual world she throws, the bottle smashes. You go to a close world in which she doesn't throw and the bottle smashes anyway. Looks like she's just not responsible for the smashing. If the bottle was just going to smash anyway, right, regardless of her throw, then it looks like she's just not responsible for it. If you go to the closer worlds in which she throws, it doesn't throw and the bottle doesn't smash, then it does look like without her throw, the bottle wouldn't have smashed. Okay? People have questions? I know that this is sort of difficult, so questions of the kind, I don't get X, are fine. Yeah?
I can just think of some everyday examples where it wouldn't really fit in a counterfactual sense. So, for example, there was some guy who threw a kitten in a river and started drowning.
Mm.
There was a guy who just happened to be running past and saved the kitten.
Yeah.
Framing the counterfactual is if the guy had not been running past the river, the kitten wouldn't have drowned.
Yep.
And that makes sense according to our counterfactual theory.
Yep.
But we would still never say that the guy who ran past the river and did not save the kitten caused the kitten to drown.
Okay, so all I've given you so far is an analysis of the counterfactuals, right, of when a counterfactual is true and false. I haven't yet hooked it up to causation, so let's do that now and see if that helps, okay? So here's the analysis of causation. You've got counterfactual dependence between two events when two counterfactuals are true. So X counterfactually depends on Y, just in case. If X had been the case, then Y would have been the case. And if X hadn't been the case, then Y wouldn't have been the case, right? So they sort of co-vary with each other, right? Change one and you change the other, right? Don't change one, the other one doesn't change, okay? We then understand causation in terms of counterfactual dependence. So X causes Y is true, if there's a causal chain leading from X to Y, consisting of events A, B, and C, right? So you imagine a whole bunch of events leading from the cause and the effect that you're interested in, such that each pairwise, each step in the chain, each two members of the chain, counterfactually depend on each other, or one counterfactually depends on the other, right? Such that C depends counterfactually on B, B depends counterfactually on A, and so on back to X, right? So you've got this series of events, and each one in the chain counterfactually depends on the previous one, and you've got causation just when you've got a chain of that kind, right? So it's similar to the kind of causal lines and causal processes that we had in the process theory, where you've got some sort of like chain of some kind, right? That was underlying the processes. In this case, it's underlying the counterfactuals. Except that the steps in the chain sort of rest on these counterfactual connections, and the counterfactual connections are given by that semantics. So in the case that you were giving, Trillo, where you've got the guy who's running past and who saves the, cat from the river, there's no causal chain leading from him to the cat getting in the river, right? But there is a causal chain because the cat's being in the river doesn't counterfactually depend on him running past. So the cat's death isn't going to counterfactually depend, arguably, I mean, it does get a little bit tricky, on him running past, right? But if there's a causal chain leading from some other person to the cat's drowning, then there will be causation.
Make the same claim about watering the plants.
Could you make the same claim about watering the plants? So in the watering the plants case, there is a causal chain of events, it looks like, leading from my failure to water the plants to the death of the plants, if you can count a failure to water the plants as an event, right? So I mean, not watering the plants turns out to be an event that the death of the plants counterfactually depends upon. If I had watered the plants, then they wouldn't have died. If I hadn't watered the plants, then they would have died, right? So you can see there's counterfactual dependence there. But in the cat case, you've got to think about what the counterfactual dependencies are, right? And that means sort of running through some of the counterfactuals and testing them. Okay, so here's a very simple causal chain. Susie throws, the rock hits the bottle, and the bottle shatters. The bottle's shattering counterfactually depends on the rock hitting the bottle, which counterfactually depends on the throw. Okay, so no process is required, though it can be used to model process causation. So imagine a causal process, a world line with an interaction. You can formulate counterfactuals involving those things. If the world lines had not intersected, if there had not been an interaction, then there wouldn't have been a conserved quantity transferred, and so on. And it can handle absence causation, as we just saw, because when you've got the plants failing to be watered, it looks like there is counterfactual dependence of the death of the plants on my failure to water the plants. Okay. We'll save your question to the end. I just want to get to the one of the counterexamples. There are lots of counterexamples, and we can talk about some of these in the queue. So here's a counterexample. Two kids are throwing rocks at a bottle. This is called preemption, right? Billy throws, and the rock hits the bottle. The bottle shatters. Susie throws, the rock hits the bottle, and the bottle shatters, right? But at the same time that Susie throws, Billy throws a rock as well. And Billy's throw is on target. It's just that Susie's rock gets there first, okay? If Susie hadn't thrown the rock, the bottle would have shattered. Why? Because Billy's rock would have hit the bottle and shattered it. So there isn't counterfactual dependence of the shattering of the bottle on Susie's throw. It's not the case that if Susie hadn't thrown, then the bottle wouldn't have shattered. Right? That's just false, because Billy's throw, in this case we say preempts Susie's throw. Right? His throw would have smashed the bottle even if she hadn't thrown. So we go to a world in which he doesn't throw. That's very similar to our world, with the same laws of nature, in which Susie doesn't throw. What happens? The bottle smashes. Why does the bottle smash? Because Billy's in that world too. And Billy's throwing rocks in that world, because we haven't changed anything about Billy, and Billy smashes the bottle. So the closest world in which Susie throws and the bottle shatters is actually a world in which Susie doesn't throw. The closest world in which Susie doesn't throw and the bottle shatters is a world in which Billy throws, and those worlds are much closer than any of the other worlds. So this is preemption. Here's another case, trumping. Major and sergeant are shouting orders to their soldiers.